Hello, welcome. Today we're going to be looking at turnover frequency and dispersion as it relates the rate of reaction. Now, we are looking at the 3C of the same question we are looking at before. The reaction involved the use of commercial catalyst of 1 weight percent platinum catalyst of molecular weight 195. The catalyst dispersion percentage of atom exposed determined from chemisuction was found to be 50% at a maximum turnover frequency of 5 molecules per SI per second and minimum turnover frequency of 3 e to the power minus 3 molecules per SI per second. Calculate the maximum and minimum rates of reaction in mole per gram per catalyst per second. Solution: using the equation, the general equation for solving this is this very equation, minus RA equal to FD. F is a turnover frequency, D is a dispersion, into bracket 1 over molecular weight of the catalyst times percentage weight of the catalyst all over 100. So here MW is molecular weight of catalyst and it's given as 195%. So R, in place of RA, you are putting R maximum. You are using the maximum turnover frequency to calculate R maximum. To calculate R maximum, which is maximum rate, and we use the minimum turnover frequency 3e to the power 3 to calculate the minimum rate of reaction. So if you substitute everything, you get 5 times 50 times 1 over 195 times 1 over 100 to give us 1.28 times 10 to the power minus 2 mole per seconds gram catalyst. So we'll do the same for the second one, R remain to be equal to 3 times e to the power minus 3 times 50 times 1 over 1 over 195 times 1 over 100. If you clear everything, including 5 and all this, you will get only e to the power minus 3 all over 130, which will give you e to the power 3 is 0.0498 all over 130 to give us finally 3.83 times 10 to the power minus 4 mole per seconds gram catalyst. So very, very important. That's how you relate turnover frequency to dispersion. So turnover frequency is actually the amount of products that are being turned over for a dispersion, and dispersion is actually the amount of metals that are dispersed on the support or the catalyst. So whenever you're relating this turnover frequency and dispersion to rates of reaction, so this is the actual equation that you use, minus RA, as rate of disappearance of A is actually equal to turnover frequency times dispersion into bracket 1 over molecular weight of the very catalyst you're using, close the bracket, then percentage of weight of the catalyst that is used in this very reaction all over 100. And in this case, we are looking at 1. So this is 1 WT. That's how you got this percentage WT. That's how we got it to be 1. Then this 50% is actually the dispersion, whereas 5 is the turnover frequency for the maximum, and 3 times e to the power minus 3 is the minimum turnover frequency rate. So fix this in this equation, you get this. Thank you, God bless you. Click on the subscribe button, like, share our videos. See you when I see you. Thank you.